I had every intention of just skipping right past this section, recording this section, and going ahead with the build and then showing you a few stills after the build was completed. But there are some details to this step of the process that I wanted to show you that I think are worthy of videotaping. This is the printed circuit board that goes into the velamin enclosure, and what I did was, with the circuit board in place, I marked out along the outer edge where the screw heads of the trim pots would align, and then I also measured how deep below the edge the top of the screw heads were, and then I marked it out on the front, or on the side of the velamin box, so that I could drill the holes so that they would end up directly in front of the screw head terminals, or the screw heads of the potentiometers. And of course, perfection. So that worked out extremely nicely. And I also want to show you the high current terminals. Now this is pretty important. I bought some collared nylon washers. I'm going to go to macro mode. I want to show you this. You can see how these washers have a raised collar on them. Got to get this in focus. That's the problem with fixed focus camcorders. But you can see the collar on the edge of this washer. And what that does is, when I insert the stud that will be the connecting stud inside the box, okay, that's going to hold the stud from the edges of the hole that I have to drill in the side of the enclosure to pass this through. Now, the hole that I have to drill is the outside diameter of the collar, so that when I put the washer against the edge of the box, it's centered in the hole. All right. So I'm going to go ahead and drill that now. Now, let me go back into focus here. You'll probably appreciate that. Alright, so now you can see this washer sits in the opening and is centered and won't move around, and it's going to keep the edge of the terminal from touching the edge of the enclosure. Now, to get a close-up of this again. Alright, same assembly technique as inside the cell. I've securely fastened the terminal that I'm going to solder my wire to with a lock washer and a nut, so that it is extremely tight and I don't have to have that tension on the nylon washer passing through the enclosure. So I'm going to put the washer over the screw, send the screw through the case, and there's no way for it to touch the edge. Alright, put a second nylon washer on the outside, a flat metal washer, and the outside nut. Now I can make this good and secure. If I was prepared, I would have had my box wrench, and I will snug it down with that later. Alright. And now, I just put a lock washer on here, and there is my wing nut. And that is my high current connection to the input of the box, or to the MOSFET. Now I've also made sure that my spacing, where I've marked the holes, is wide enough to accommodate the ears of both wing nuts without touching at their closest point. So I'll attach my high current leads to these, and these are my low current binding posts that will be on this side that will supply DC to the circuit board. Well, here it is, the completed zero fossil fuel current regulated pulse width modulator for harsh environment applications. I've built it into the Velaman G106 enclosure. You'll notice that I have taken the voltage regulator chip and I have folded it down. You can get a little better look. You see how I've done that? It just hovers above the LM324. This terminal right here is the plus 12 volt input terminal that powers the electronic circuitry inside. Here is the power MOSFET, and look at all this room. What do you suppose I might want to do with that someday? Well, I'll give you a hint. That's extra room for another power MOSFET where I can double the output current capability of this unit. As if 110 amps continuous and 330 amps peak is not enough, just in case I want to go a little bit more brute force, I can do that. Although I don't know of too many alternators that will take that. I'll show you the wing nut terminals on the opposite side. This one is the terminal that goes to the electrolyzer cell negative. Okay, so you have it labeled cell minus, and this one is labeled ground. The cell receives its positive voltage directly from the battery, so that terminal connection does not need to come to this box. Positive goes to the cell, the negative terminal of the cell comes to this terminal on the pulse width modulator, to this terminal on the pulse width modulator, and then this terminal goes to ground, and that's the complete circuit that runs through the cell. You'll see on the side here, I have the trimmer potentiometer labeled I for current, the percentage symbol for duty cycle, and F for frequency. The only thing that's left to do to this device is to sign it. So, let me sign this on camera for you. You have heard of the mark of Zorro? I give you the mark of 0. And I'll just put the cover on now. Incidentally, I applied a little bit of Vaseline, just a very thin coating of Vaseline to the O-ring seal on the cover to keep it from sticking. So if this cover ever needs to come off, it can come off very easily. And there you have it. There is the completed pulse width modulator. So what I'm going to do now is I'm going to bring it out to the garage, I'm going to test it under load, and I'm going to observe the output waveform on the oscilloscope and record that for you.